Hello and welcome back. In this video, we'll begin working on writing our connection classes and try to send some game information to a connected client from our server so we can configure Pygame on the client end. So let's head over to the server script and begin. So if we look, we're already creating a connection object, my connection, all the way down here at the bottom of our script. So what we need to do is we actually should probably write this connection class right now. So our connection class is right here towards the top. We just have an initialization method, so let's fill in this initialization method as we start here. So the first thing that we'll do is we'll add some attributes to the connection class. In particular, I'll add I'll do I'll add an encoder, self.encoder, and I've been using UTF-8. And I will then set a header length. Now, in past videos, we've been using like that byte size constant. We're not going to do that here because we're not going to just set an arbitrary maximum byte size. Instead, we're going to use a fixed length header for every message packet that we send. We'll send the header first, which will have a fixed length of, say, 10, and it will indicate how big the next incoming package is going to be, and then we'll send it over. And so this is going to make things work so much better for us here using this new updated method. So we'll say self.header length is equal to 10. Awesome. Now what we'll do is let's create a socket for the connection class. So we'll say create a socket, bind, and listen. So we'll do self.server socket is equal to a socket.socket, and in here we'll pass socket.af_inet. There's IPv4, and we'll do socket.sockstream. There is our TCP connection. Next, let's bind it to a specific location. So we'll do self.server socket.bind, and where do we want to bind it? It's got to be a tuple. Well, we've got our host IP and host port right here, so let's set those values in. So we'll do host IP, host port. Wonderful. And now that the socket's created and it's at its location, we just got to listen. So we'll do self.server_socket.listen. Excellent, excellent, excellent. So while we're here on the script file, let's see what else we're doing right when we start our server. So let's scroll back down. So if I scroll back down here, we see we create a connection object. Perfect. We're also creating a game object. So why don't we go work on writing the game right now? And it's kind of great. We're actually feeding it the connection object that we just created, so that will work out really nicely. So let's go to our game class, and let's work on the game's initialization method. All right, so we'll get rid of pass. And here, the first thing that we'll do is we're passing in the connection object. So let's set that connection object as an attribute of our game class. So we'll say self.connection is equal to the connection object that we just passed in. Awesome. So now we can access that in any of these other methods. Let's also set some things that are going to help us sort of keep track of the game on the server end. For example, let's set a player count. So self.player count, and we'll initialize it to be 0 because right now nobody is connected to the game. Now we're going to, every time someone does connect to the game, if you recall, we're going to be creating player objects for each client that connects. So I want to keep track of these player objects. So I will have a list, self.player objects, and we'll initialize it as a blank list. And then I'm also going to keep track of all of the sockets that correspond to those specific players. So self.player socket. Sockets, I'll say, sockets plural. So when our first client connects, they'll get a player, it'll be at index 0, and then we'll have their socket at index 0. The next client connects, they'll get a player at index 1, and their socket at index 1. So that's going to, I think, correspond kind of nicely here. And lastly, I'll create an attribute round time, and we'll set it to our constant variable that we've defined up here, round time. And this is going to help us control how long a game takes from the server side. So if you remember, we're going to keep track of everything time-wise on the server and then push that out to all of our connected clients. So everyone's in sync, essentially. So we'll do self.round time is equal to that constant variable round time. All right, wonderful. So now that we can initialize instances of our connection class and our game class, we're going to try to call the game class's connect players method. That's the last thing we do down here to sort of start our server, right? We initialize our connection, we initialize our game, and now we're calling connect players. So let's try to write this method for our game class right now. So if we scroll up, we find connect players right here inside of our game class. All right, so let's talk about what we need to do in this method. So we're going to have a constantly running loop that is going to accept clients as they join the server. However, we don't want to accept all clients. We only want to accept clients as long as there's room in the game for them. So if you recall, we have a variable, a constant variable, total players. So as long as the game's player count attribute, which is currently set to 0, as long as that player count is less than the total number of players we're expecting, we should just keep running this while loop, listening for incoming players. So we'll say only accept players if the player count is less than total players. So we'll say while self.playerCount is less than our total players constant, we'll accept incoming player socket connections. So when we call the accept method, if you recall, we are going to get two pieces of information. We'll get the player socket and the player address. So let's grab them. And I think in the past I've been calling them like client socket, client address. But here I'm going to call them player socket and player address just because, this is the nature of a game. So we'll say player socket and player address are equal to self.connection.server socket. So this is how we're going to access the server socket from inside of the game. The game has access to a connection object. That connection object has our server socket. So we'll call that, and then we'll call .accept here. All right, perfect. So now we have essentially allowed someone to connect. So what we want to do is we want to send some information over to that player who just connected. Really, whoever's running the server has the power to tweak a lot of aspects of gameplay for every single person that is connected to the server. They can change the size of the game room. They can change how long a round lasts, the total number of players, the frames per second that should run on a client. And these are all of the constants that we defined on the server end here. So let's send all of those constants over to the player that just connected. We should note, though, that all of these values, so if we look up here, all of these values are integers. So in order to encode them and send them, what we'll have to do first is cast them to strings so that we can encode and send. And recall, we're going to use our fixed length headers here to send everything. I think for this point in the game, it might be a little overkill, but it's going to be super helpful for us moving forward to kind of just get into this habit of using the fixed length headers. So I'm just going to go ahead and do it here anyway right now. So let's send, once the player has connected, let's send over some information. So we'll say send the current game configuration values over to the client. All right, so the first thing that we'll do is we'll do the room size. So we're going to get a header, and we're going to get the length of room size, but room size is an integer, so we can't do that. So we got to first cast it to a string. So we'll get room size. So what do I mean by that? Well, if the room size is 700, what is the length of 700? Well, it's an integer. It doesn't have a length. But what is the length of 700 as a string? The length is 3. And so that's going to work nicely for us. Of course, that is now an integer, and we really want that value to be a string, because what we're going to do is we are going to append a bunch of white space to it as long as it's not the correct header length. And so it's not the correct header length right now if it's 700. It's only 3 characters long. We need it to be 10 characters long. That's our defined header length. So we'll say while the length of our header, and we can do this now because header now is a string, so we can take the length function of it, is less than our header length. And our header length is stored in our connection object, so self.connection.header length. All right, so what are we going to do here? Well, we'll take our header and we will simply add a white space to it. So now we'll build up our header. So instead of maybe saying 700, it will say 700 with, that's 3, 4, 5, 6, 7, 8, 9, 10 spaces. So that's what it's going to turn into. And I'll leave that as a little comment right there. All right, I'll just put that as a comment. So that's what our header is going to turn into. Now that our header is the correct length, let's send it over to the player that just connected. So we need their socket. Well, we have that socket right here. So it's within this method. So we can say player socket dot send. The first thing we'll send is the header, so header, and we have to encode it. It's a string, so we can encode it right now. So we'll say dot encode, and we'll pass in an encoder. Our encoder is stored within our connection object, so self.connection.encoder. Awesome. Now that will say, hey, we have an incoming message, and that message is going to be, I don't know, however big it is. So let's send it over. Oh, this is wrong. This is wrong. This would be 3, right? 700 has a length of 3. So the header is 3, and then this would turn into 3 with, an accurate amount of spaces in it. I'm actually just going to get rid of that comment because I think that's a very confusing comment right there. Now let's send over the actual information. So we'll do socket.send, and we want to send over the room size, but we have to make sure it's a string so we can encode it. So we'll call str room underscore size, and then we'll call dot encode, and we'll pass in our encoder, which is found in our connection object, so self.connection.encoder. All right, so that is kind of like the process for sending these initial game configuration values over. So what I'm going to do is I'm actually going to copy it. I'm going to copy this whole thing, and we're going to paste it, I think, 3 more times, because we're going to send 4 pieces of information here right now. So we'll do 1, 2. All right, so here's our second one. Our second piece of information that we'll send over, I'm just going to change room size to round time. And we'll change room size to round time right here. And then we'll do another one. All right, bring this to the correct location. The next thing that we'll send over is our frames per second, FPS. And then our last thing that we'll send over is our total players. So the total number of players we expect. Total players. All right, perfect. We're not going to send over the player size because what we'll do is we'll send that over when we actually create a player here. So why don't we actually work on actually writing that player now? So on the server end, right, the player's connected. So we've accepted someone. We've just sent them all of the current game configuration values. The next thing that we have to do is we have to create a player for them. So we'll say create a new player object for the connected client. So we'll say, hey, we're creating a new player. So I'm going to take my game's player count attribute, and we'll add 1 to it. We'll increment that, and then we'll create a new player object. So we'll say player is equal to a player object. And what does a player object need to be initialized over here on the server? All it needs is a number. Well, which number is it? Is it player 1, player 2, player 3, player 4? Well, thankfully, we've got a attribute here in the game that we can just pass in. So we'll say pass in self.playerCount. So that first player that we create will, in fact, be player number 1. All right, now, since we made a new player, we've got a couple of lists, I think, in the game object that are going to help us keep track of things. If we just scroll up, we look, we've got a player objects list. We should append our player to this, and we have a player sockets list. We'll append this player's socket to that list as well. So we'll come over here and we'll say self.player_objects.append, and we'll append the player object that we just created, and then we'll do self.player_sockets.append, and we'll take this current player socket and append it into this list. And then I'm going to put some visual feedback on the server. I'll say print, and we'll do an f string, and I'll say new player joining from, and then I'll put their player address, so their IP address. And that player address is something that we grabbed right here when we accepted that connection. And we'll come down here. I'll finish formatting it. I'll do ... and I'll actually indicate the total number of players as well. So I'll say total players is, and then in here we'll put our player count. So self.player count. So when the first person joins, it'll say, hey, new player joining from, it'll give their IP address, and it'll say total players 1. I think that's going to be some needed visual feedback on the server end. So this is all happening if only when our player count is less than total number of players. So what do we want to do if it's not? So like when this while loop ends, let's break out of this while loop here. So we'll break out of the while loop and we'll just say maximum number of players reached, no longer accepting new players. So let's just print that to the server. So we'll print and we'll say f-string. We'll do an f-string here, and we'll say total players, whatever our total players. So if it's 4, it'll say 4 players in game, no longer accepting new players, ... All right, so that'll just let us know that we are, in fact, ready to go. All right, so I think for right now, our connect player method looks pretty darn good. We're sending a lot of information over to the client at the start of the game about how the Pygame should be configured. I'm going to save this, Control S to save, and let's head over to the client now. And let's actually see if we can quickly receive some of this information. So I'm going to scroll down. And where are we receiving this information? We're receiving the information right after we make a connection. So we're creating a connection object here. When we create that connection object at the start of our actual code, we have no connection object right now. So we actually have to write this connection object. So that's easy enough. Let's write this connection object quickly. So we'll put some information in here, like attributes. We'll do self.encoder again, and we'll set the encoders to be the same. So it'll be UTF-8. And let's set a header side. So we'll say self.header length is equal to 10. And then let's create a socket and connect. So as soon as we create the my connection object, it will create a socket for us and connect to the server. So we'll do self.player socket is equal to socket.socket. And inside of here, we'll call socket.af_inet. And we'll do socket.sock_stream. And now we'll connect. So self.player.socket.connect. And where are we connecting to? We are connecting to our destination IP and our destination _port. Perfect. So we're going to go back down now to the bottom of our code. But no, when we create our connection object, we are connecting to the server right here. So when we connect to the server, what is the server going to do? Well, it's going to accept our connection, and then it's sending us over 4 pieces of information. So we got to grab those. But before we grab the information, what we really have to do is we have to grab the headers, right? We got to grab the header, which is really going to tell us how big the next packet is that's coming in. So I'll call that my packet size. So if we look here, we're going to do this 4 times. And so let's kind of walk through it once, and then maybe we'll just sort of copy and paste here. So I'm going to get a packet size. So packet size from the server. So I have to access the socket. The socket is stored in the connection object. So my connection dot player socket. All right, and we're going to want to receive from the server. Now, we have to specify how big the incoming packet is. Well, it's a header, so we have my connection dot header length. All right, that'll specify how big that is. And now what we want to do is we want to decode this. This is going to be a bytes object. It's just we've just received it, so we'll decode it. Decode, and we'll pass in my connection dot encoder to get our UTF-8 encoder. I mean, we could just write UTF in here all the time, but if we want to change it, then that becomes a huge pain. So I'm going to stick to this method here. Now that we have this packet size, it tells us how large the next incoming packet is. That next incoming packet, if we come look at our server, it is going to be the room size, so how big our game window should be. So I'm going to call this room underscore size is equal to my connection dot player socket dot receive RECV. Now, how big is this packet going to be? Well, it's going to be our packet size. That's how large. This is a string, however, because we've decoded it. When it decodes, it's going to be a string. So we're going to cast it into an integer so that we can actually use it here. And then we'll call .decode, and we'll use our my connection dot encoder to decode. Perfect. But again, we have decoded a byte object, so this whole thing is going to be a string. However, you look like our room size, our window width and window height, we need these to be integers. So let's just cast this whole thing now to an int. All right, and that is going to be the process. So let's copy this whole thing. And we said we're going to send and receive 4 things. So let's paste. There's our second, our third, and our fourth. And all we have to do is kind of just change the names. So what's the second thing we get? The second thing we get from the server is our round time. So we're going to get a packet size that indicates how large the next incoming packet is. And that next incoming packet is not room size. It is round time. All right, and then we're going to get a packet size from a header, and it's going to tell us how big the next packet is. That next packet is not room size. That next packet is our frames per second. So we'll call this FPS. And then we're going to get another packet size from a header that tells us how big the incoming packet is. That next packet is not room size. It is the total number of players. So we'll say total players here. Awesome. Now, I do think, maybe it's a little overkill to use fixed length headers here to just send over some integers, but I want us to get into the habit of using the fixed length headers to see how it works, because we're going to use them, extensively throughout these videos here. So the last thing I'm going to do is I've hard coded a lot of Pygame values, so let's change them so that they're dynamic. So the window width, I'm going to set it to be the room size that I received from the server. Same thing with the window height, so room size. Same thing with round time. We'll set it to round time, the round time that I receive. Same thing with FPS. Let's change our FPS from 30 to whatever value we get from the server. And then lastly, don't forget, I've got total players here. If we scroll down, when we created our game object, we required a total number of players. We hard-coded that as 4, so we're going to take that out and we'll just write total players here. So now if I run, you see our server, what are these stats right here? Room size of 400. So let's just see. If I run my server, oh, we have an attribute here. It says server socket. None type has no attribute server socket. Okay, so let's go see what this error is that I have here on my server side. This is on line 71. 71. Self.connection.server socket. Server socket. I'm going to pause the video and debug this, and I'll be right back. Oh my goodness, what a silly mistake. I made this mistake. You hopefully did not make this mistake. You probably were watching one of the last videos going, what the heck is this guy doing? Where I'm defining my classes, right? I got class player, I have class game. Look what I did. I wrote def connection. It's got to be class connection. I'm so sorry about that. I was just moving really fast, and that was a silly mistake. So when you declare a class, you have to say, hey, this is a class. And then when you declare the methods, you define them. So now let's try running this now. All right, server is listening for incoming connections. Let's run the client. Let's see if we get our gameplay information correctly. Okay, so we have one last error here. It says my connection is not defined. Did you mean my connection? I did mean that. I must have spelled it wrong. So if I go down to line, this looks like it's on line 104. My connection. So I'm going to show you something interesting. Because I copy and pasted that error over and over again, I can actually hold Alt and click, and I'll get multiple cursors here. So I'll say my connection. Let's make sure we spell connection correctly here. C-O-N-N-E. C-T-I-O-N. I think that looks correct. My connection. All right, so now we've made those appropriate changes. Let's try one more time. So we'll run our server. That's just how it is. You got to debug these errors, and they happen. Even when you think you know what you're doing, small typos can get you. Header length. Oh my goodness, I have another error. I am so sorry about this, folks. So my connection.player.socket.receive.encode. Did I spell header length wrong the entire time? I did. So let's do a quick fix here. My apologies. All right, we'll save it, and let's try one last time. I'll close these out, and let's run the server. What should have been, maybe a minute to test is now turning into like 3 minutes. Apologies. All right, so there we go. No more errors. And it looks like we got some game window information from here. Let's change the game window on the server, and let's see if it changes here. So let's update this to like, I don't know, 700. So we changed the room size on the server, and so now hopefully those changes are going to be pushed over to the client. Oh, you can only have one server running at a time. Silly me. So we'll run these. All right, server's listening, and we run, is our window going to be bigger? And it is. Awesome. So it looks like, the server, when we connect to client, the server is sending all of our gameplay configurations over to the client, and then the client is using them to adjust on their end. This is working out really perfect. So here's our connect player method inside of the game class. We can see that whenever we get a connection, we accept a connection, we send over all of that game configuration information, but then we're creating a new player for the client. So we should go initialize the player class here on the server side so that we can then send that player object over to the client who just connected. So let's scroll up to the player class. All right, and in its initialization method, we'll start. So the first thing that we'll say is we have a number that has been passed in. We'll attach it as an attribute to the player. So we'll say self.number is equal to number. Next, we are specifying the size of the player over here on the server as one of the ways that we can change gameplay. Do we want the players to be really small so they're hard to collide, or do we want them to be really big so there's tons of collisions? So we'll set that as an attribute. So self.size is equal to our constant variable player size. And lastly, I will also add a score for the player here. So I'll say self.score is equal to 0. We're going to do the majority of the scorekeeping on the server side, and then we'll pump those scores back to all of the connected clients. Now, based on the assigned player number, whether they're player 1, 2, 3, or 4, we're going to give some specific starting conditions for that player object. Mainly, we'll set their starting position, so whether or not they want to start in like the upper left-hand corner, right-hand corner, bottom left-hand, bottom right-hand corner, like their home position, and we'll assign some colors, like a primary and secondary color. So let's go ahead and do this here. So we'll say assign starting conditions that vary with player number. So we'll say if self.number is equal to 1, what do we want to set? Well, we're going to set a starting X and starting Y position. So self.starting underscore X, we'll put that as 0. Self.starting underscore Y is equal to 0. So that means if you're player 1, you're going to start up here in the upper left corner of the game window. And then let's set some colors. So player 1 will be red. So we'll do self.p color, p underscore color for primary color is 255, 0, and 0. So that's going to be all red, bright red. And then self.s color, or secondary color, will make it like a darker red, 150, 0, and 0. All right, perfect. So now I'm going to just copy this, and I'll paste it down below, and we'll put an elif. So elif, player number is 2. Okay, so player 1 started here. Player 2 will have start all the way over in this corner. So we want to use, that corner is going to change depending on how big the room is. So we're going to use our room size variable. Now, our starting X, we don't want it to just be room size, because the starting X is going to be the left side of the player. So if the left side of the player is at the room size, that means the player is going to be like off the screen. So we're going to take the starting X position and do our room size minus whatever the player size is. And that will ensure that rather than starting the player like right here at the edge, they'll start the player over here, and it will fill in this region of space. Awesome. Starting Y will still be 0, okay, because we're starting at the top. In Pygame, Y, in the Y direction, 0 is at the top, and then you increase as you go down, so that's important to note. Our primary color for this player will do green, so this will be 255 here, and then we'll do a dark green as their secondary color, so 150. I will copy this, and I guess just I guess I could have just pasted. So we'll paste. Now we'll do a condition for number 3. So elif number 3. Where are they going to start? So let's see. They're going to start in the bottom left-hand corner. So the x position is going to be 0 here. But what will the y position be? Well, the y position is going to be room size. We have a square room. But again, it will put the top of the player there, so the player will be off the screen. So we're going to subtract. We're going to subtract the player size to just put them up. So the top is right here, and they fill in that space. So we'll do room underscore size minus player underscore size. All right, that looks great. Their color will be, let's do blue, right? So we'll do 255 in the blue channel for our primary color and 150 in the blue channel for our secondary color. And then we've got player number 4. Player number 4. So we'll paste, and we'll back this up, and we'll say if number is player 4, where is their starting position going to be? It's going to be the bottom right-hand corner. So essentially our x is going to be room size minus player size, and our y is going to be room size minus player size. And this color will make yellow. So we'll do 255 and 255 equal red and green portions will make yellow. And then our secondary color will be a duller yellow. So we'll do 150 and 150 in the red and green. All right, perfect. I always like to have an else block just to catch, I don't know, just in case. So I'll just say else. We'll print too many players trying to join. I don't think it will happen, but let's just put an else block here just in case. Okay, perfect. So those are going to be the things that vary. I'm going to get rid of these spaces in here. We don't need those. So we'll just compact that all together. All right, perfect. So those are going to be the starting conditions that vary depending on whatever the player number is. But now we're going to have some attributes that are just straight across the board. So let's set those. So now we'll say set the rest of the player attributes. In particular, we're going to have, let's see, we're going to have an x coordinate. So we'll say self.x, and we're going to assign it at the beginning as our starting x coordinate, so starting x, and we'll do self.y is self.starting y. All right, we're going to need a dx and a dy variable to help us move across the screen to indicate, what direction we want to currently move in. So we'll say self.dx is 0 and self.dy is 0 because upon the game starting we're not going to be moving, but if I hit like the right key then this will change to 1. And then let's create a coordinate. Self.coord is equal to our self.x, our self.y, and so that's going to be our starting position, x and y, so like 0, 0, and then we're going to use this as like a rect. So we got to express how big we want to be. Well, we want to be player size in both the x and y directions. So that's going to be self.size and self.size. All right, awesome. The last thing we'll do is we'll set some Boolean flag variables to help us keep track of the state of the player. And so we're going to use these Booleans to change the state of the game. So like, whether the player is waiting to play, if they're ready to play, or if they are in fact playing. So we'll say self.isWaiting is equal to true. We'll do self.isReady is equal to false. And we'll do self.isPlaying is equal to false. And then let's create a status message that we attach to each player object. And what we'll do is we'll render this status message to the game window at all times. And we'll update the status message depending upon what the status of the player is. So like we'll do self.status message. And for right now, since they are currently waiting, they're waiting to play, we'll just say, we'll put an F string in here, we'll say waiting for total players, and I think that will look good. So like when we first join, we can't do anything until everybody gets in the game. So it'll say, the status message will say like waiting for 4 total players. So we're just kind of waiting right here. All right, perfect. So now that we've written the player class in our game's connected player method, after we connect the player, we should send the player over to the connected client to help sort of initialize it on their end. So if we look, let's scroll down to our game class, and we're going to scroll down to our connect players method. So here we're creating the new player object. What we now want to do is we want to send this player object over to the connected client. So we'll say send the new player object to the connected client. Okay, so how are we going to do this? Well, what we have here is a player object, right? It is a Python class. What we need to do is we need to turn that class into a dictionary, which will essentially be associated key value pairs of all of the class's attributes. Then we'll take that dictionary and turn it into a string using JSON so that we can encode it and send it. And of course, we're going to use fixed length headers to help us to ensure that our class sends with no issues. So let's walk through how we are going to do that here. So first, I'm going to create a variable, I'll call it player info JSON. And we're going to use json.dumps. And what do we want to turn into a JSON? Well, we want to turn in our player object. So our player object is called player right here. But you can't turn a class into a JSON object. However, we can call dot underscore underscore dict underscore underscore on our player class, and this will take our player and turn it into a dictionary. So all of those attributes that we just set will become key value pairs in that dictionary. That dictionary we can use JSON on to turn it into a string. So now that's a string, so we want to send it. Well, first let's get a header. So we'll say header is equal to the length of player info JSON, but we want this is going to be an integer. We want that to be a string so we can add some white space to it. So now we'll say while the length of header is a string now, so we can use the length method on it, or the length function. While the length is less than our header length, so that's stored in our connection object, self.connection.header underscore length, and I'll spell it correctly this time. We're going to add some white space, so we'll do header plus equals a white space character. Now let's send the header. So player socket.send. Recall, we're in the connect player method, so we have access to the player socket right here directly. So we'll do player socket.send. What do we want to send? Well, we'll first send our header, and we'll encode it. So header.encode, and we'll pass in our encoder, self.connection.encoder. All right, that encoder is stored in our connection object. And now we'll send over the player info JSON. So player socket.send. And we'll say player info JSON.encode, and we'll use our encoder again, self.connection.encoder. Awesome. I think that's pretty good. So now a player has joined. So let's broadcast to every single person that is connected to our server that someone else has joined. So we'll just say alert all players of new player joining the game. And so we have a method to do this. We have a broadcast method. So we'll call self.broadcast. And let's go write the broadcast method right now. All right, so we're going to come down here to broadcast. Okay, so what we want to do in the broadcast method is send information to each and every player connected about all of the players connected. So to do this, we're going to create a blank list called game state. So I'll say game state is equal to a blank list. And now we'll turn all of our player objects into dictionaries, like we just saw how to do, and then into strings through JSON, and we'll append them to the game state list. So we'll say turn each player object into a dict, then into a string with JSON. So we have a list of all player objects that are currently connected to the server. It is in our game class. It's right here, player objects. And so that's going to help us out. So we'll say for player underscore object in self.player underscore objects. So we're going to loop through that. So if there's like 4 players, we're going to loop through this 4 times. We're going to get a JSON string. So player JSON, we'll call it, is equal to json.dumps. What do we want to turn into a string? We want to turn into a string the player object, but player object is a class. So we'll have to do dot underscore underscore dict underscore underscore to turn this class into a dictionary of, so all of its attributes are associated key value pairs. JSON will then turn that into a string. Perfect. Now that that's a string, let's append it to our game state list. So we'll do game underscore state dot append player JSON. Perfect. So when this is all done running, game state, if there's 4 players, we'll have 4 elements in there, and each element will be a string describing our player. So that's perfect. So this will run when someone new joins the game. So we'll say, now that someone else has joined the game, send the game state to all players. So we have a list here that we want to send through the data stream, so we have to encode the list. Well, in order to do that, we'll use JSON, right? You have to turn it into a string. So we'll call this game state JSON, and this will be json.dumps. And what are we going to dump? We're going to dump our list game state. So now we have a string representation of that list, which we can encode and send. Well, let's use fixed length headers. So I'll say header is equal to the length of game state JSON, but this is going to be an integer, and we want it to be a string so we can add some white space to it. So we'll cast it to a string. All right, now let's actually add that white space. So while the length of our header is less than the header length, which is stored in our connection object, self.connection.header underscore length, we'll add some white space. Header plus equals a white space character. That will ensure that it is the correct size. And so now what we'll do is we'll send the header and then the game state to each and every connected player. And we have a list of all of the sockets where we need to send them to. It's our player sockets list. So we'll say for player underscore socket in self.player underscore sockets, let's send this information. So player socket.send, the first thing we'll send is our header, and we'll encode it, .encode, and our encoder is in the connection object, so self.connection.encoder, and then we'll send over the game state. So player socket.send game state JSON dot encode. It's a game state JSON's a string, so we can encode it, and we'll use self.connection.encoder. All right, so that's going to work out pretty good, I think. That was a lot. I think that was a lot here, but this is going to be a great function to sort of help us. So anytime there's game state changes and we want to push them out to all players, we have our broadcast method here. I think this is a great place to stop. All right, so here is our player object, and here is our init method. So inside of here, we know that when we make a connection to the server, our server sends over the game settings, like window time and round time, and we've already received all of those. The next thing in the data stream that the server is going to send is the player object that the server has created, right? If we just look over here, here is our, where's our game object? Here's our game object. So we just sent all of the game configuration stuff over on the server, and now we are sending the player object. So we're sending that header, which is going to be our packet size, indicating how big the next packet is, and then we're going to get that player info. So we should probably receive them right here at the start of the player's initialization method. So we'll say receive the player information from the server. So the first thing that we'll get is the packet size of the next message that's coming in. So packet size is equal to our connection object, and in here we have our socket, so connection.player socket.receive, and the size of this is going to be our header length, which is also in our connection object. So connection dot header length, header underscore length. And then we need to decode this because this will be encoded. So we'll do decode, and we'll pass in our connection object dot encoder. Oh, encoder. That's not a function, so we'll just do encoder here. Okay, wonderful. Next, we'll get the JSON that's coming in, right? So we'll say player underscore info underscore JSON is equal to connection dot player socket dot receive. And this time, what is the size of this incoming message? Well, it's packet size. So we'll turn that string into an integer so we can use it here, packet size. And we will say that That is perfect. We don't need to decode here because this is a bytes string object, and we want to turn it back into its dictionary. So we'll do the decoding and turning it back into a dictionary in one step with the JSON loads method. So then we'll say player info is equal to json.loads player info JSON. So right here now we take that byte string and we decode it and turn it into a dictionary. Perfect. So now we have a dictionary of key value pairs that were associated with our player object on the server side. So what we'll do is we'll set those attributes to our player now on the client side. So we'll go through and we'll say set the player values on the client side. So we'll say self.number is equal to player underscore info, and then remember player info is a dictionary and we're going to access the number key. So whatever is stored in the number key, that value will become our player's number over here. And we'll do something similar for our size. So we'll do self.size is equal to player underscore info, and then we'll pass in the size key. So if we look, what are some of the other attributes that are in this dictionary? We just have to come over to our player class. We've got number, we've got size. Score, we're going to skip. I'm not going to worry about initializing the score. I mean, I could, but I don't think I'm going to use it at all because we'll keep all of the score on the server side and then push it over later. However, our other attributes I do want. So we'll do self.starting x is equal to player underscore info square brackets starting x. And then I'm going to do a little bit here. I'm just going to copy this line and I'll paste it 1, 2, 3 times. We'll do that. And what I can do is I'm going to put my cursor here. I'm going to hold Alt and put my cursor here, and I can delete starting x. And now I'll type in my next value, which is starting y underscore y. I'll do the same thing down here. So I'm holding Alt to have the multi-cursor. We'll delete starting x. The next key will be our primary color, or p underscore color. And then the next one here will be our secondary color, or s color. So we'll just delete, and we'll do s underscore color. And now I'm going to have another slew of values. So I'm going to paste 5 more here. 1, 2, 3, 4, 5. And what are these attributes going to be? Well, we're going to have an x value. So we'll do x. We'll do a y value. So we'll do y. All right. We're going to have a dx and a dy. So we'll come over here. We'll clear these out. Dx. And we'll clear this one out and make it dy. And then this last one will be our coordinate, which is that tuple that specifies where our rectangle should be drawn. So we'll do chord. All right, and then our last set of attributes here on our player on the client side is going to be all of our status flags. So we'll have 1, 2, oops. Let me go on a new line here. 1, 2, 3 status flags, and then a status message. So the name of those status flags are going to be, clear that out, we'll say is waiting. Our next status flag will be is ready. And our next status flag will be is playing. And then our last attribute here will be that status message, which we are always printing to the screen. So we'll say status message, or rendering to the screen, I should say. Okay, so that looks pretty good. Our server is going to create a player, and then it's going to send that player over to a connected client, and we're going to set all of our attributes based off of that information. And our server is going to update that information depending on whether it's player number 1, player 2, player 3, player 4. I think that looks pretty good. So if we run this now, let's just run our server. So server's running. Okay, and let's connect with our client. Let's just see, do we get any errors? All right, no errors, so that's great. So it seems like it's working. Believe it or not, the client connected to the server sent over the game settings, which it used to build the window, and then the server created a player object, and it has sent that player object over to this client. And the client has then received that information and initialized a player on their end. It's all happening, but we don't see any indication of it happening yet. So let's head to our games, or our client's game class, to sort of change this. So we're going to move down to our game class. And what we see is if we scroll all the way down here, we see after we create a player object, we create a game object and we feed it our connection, our player, and our total numbers of players. So we're going to go in and initialize the game class next. So let's go here to our game class and we will initialize it. So we've received a lot of information when we built the game class. We're going to set these as attributes to the game class, and it will help us later on. So we'll say self.connection is equal to connection. See, just let me go back here for a second to explain. We received a connection here. If you notice, we didn't set the connection as an attribute to the player because we don't really need it. We'll access our player socket. We only needed it once just to receive this player information. This stuff we will do independent of the socket, so we don't really need that there. But we will need that connection object inside of our game class, so we better set it as an attribute here. We'll set the player, so we'll say self.player is equal to that player, my player we just created, and we'll say self.total players is equal to total players. Perfect. One other attribute we'll set here that I think will be helpful is an isActive Boolean flag. So this will keep track of whether or not the actual game is running. So, the player's got flags, is playing, is waiting, is ready, but we'll have a Boolean self.isActive here in the game object to determine whether or not the game is playing and we're just playing, different iterations of a game round. So right now we'll initialize that and set it to false when we first start the game. Okay, perfect. So now let's keep track of how many overall players are in the game. This is going to be important for us to do on each client. So we'll say set the player count to player number -1. We haven't received any game state data yet. And so what we're going to do here is you might say, okay, this player that was just created has a player number. So if it's the first player, then that player number would be 1. And so you'd think that maybe there's only one person in the game. And then if you were the second number, if you were player number 2, you'd say, oh, there's 2 people in the game. And then if you're player 3, there's 3 people in the game. And that's going to work really nicely, except when we get to our total number, whether it's 1, 2, 3, or 4, when we get to that last player, we're going to have some issues in the way that we're going to write our code coming up in the future. So what we'll do is we'll set self.playerCount, our game's recognition of how many players are currently in the game, as whatever our player number is. So self.player, we're going to access that player object, and we're going to access its number, so self.player.number, and we'll subtract 1 from it. Don't worry, we will add 1 back in later on once we receive game state information from the server about this specific player. We haven't yet received it, so we're going to do the -1 for right now. Next. Let's create a blank list that will hold the state of the current game for us. So we're going to initialize a blank list here. We'll say create a list to hold the current state of the game. And this is from the server. So we'll call this self.gameState, and we'll initialize it to be a blank list. Perfect. And that makes sense, right? We said we haven't received any game state data yet, so we're taking your player number and subtracting 1. So even if your player number is 1, our game right now is going to say that there are 0 players in right now. And let's also create, so this is going to get us the game state from the server, but let's also create some variables that are going to help us keep track of the game state locally on our own machine. So we'll say create variables to hold the state of the current game locally. All right, and so what are some of these variables? Well, let's get we'll get a round time. So for an individual round, so we'll say self.round time is equal to our constant variable round time, which we will have gotten from the server. So if the server changes how long the round's going to last, it'll update it here. We'll do a high score, self.highscore, and we'll initialize the high score to 0. And then we'll keep track of which player is currently winning a round. So we'll say self.winningPlayer, and we'll initialize that to 0. So, when we start the game, no one is currently winning. Winning players, the player numbers being like 1, 2, 3, and 4. If it's set to 0, then that means no one is winning. All right, so far, I think we're doing pretty good here. The next thing that we'll do is we'll say, okay, Yeah, let's do that next. So if we think about this, what we have is, I'm just going to pause this for 1 second. Okay, yes. So now that the game has been initialized, right? A player has joined. The game has been initialized. What we need to do is we need the game to essentially wait and see if all of the players have joined and if we're ready. So imagine if we have only 3 people in the game, but our total player number should be 4. We have to essentially wait for one more player to join. Then, once all 4 players are in the game, they're all going to have to hit enter to confirm that they are ready to play. And only when all 4 players are in the game and ready to play will the game actually begin, and our Boolean is active be set to true. Monitoring this status of the other players means we have to be constantly listening for an incoming message from our server. So only once everybody joins the server and gives it signals that they're ready, the server will pump some message back to each individual client. So since we have to constantly be monitoring, we should probably do this in a thread. So we'll create a waiting thread and have it target our receive pregame state method. If you recall, we have a receive pregame state method right here. We're waiting to receive a game state before the game starts. So we'll call that method right here. So we'll say wait till all players have joined and are ready. So we'll call this waiting thread, and it will be threading.thread. We said our target is going to be self.receive pregame state. And let's see, does that take any arguments? Let's see, does receive pregame state? Nope, it takes no arguments, so we can just have it just like this. Wonderful. And so we'll start that thread here. So we'll say waiting thread.start. All right, awesome. So we've got this receive pregame state thread running. Let's go write receive pregame state right now. So I'll scroll down. All right, and so here's receive pregame state. Make sure you are in the correct method, not receive game state, because the game hasn't officially started yet. So the pregame state here will run as long as we are still waiting for players to join. So if we're waiting for players to join, then we should be listening for incoming messages from the server, because the server is going to send that information over to us. So we'll say while self.playerCount, so that's the number of players that are currently in this version of the game, is less than self.totalPlayers, the total number of players we expect to join the game. That means there's room for another person to join. What do we got to do? Well, we got to receive some information from the server. And so let's go over to that server right here. If we look, anytime someone connects, all right, so to the server, we accept them. They send over all that game state information to the individual client. They send a player to the individual client. And then if you look, we're alerting all players of a new player joining the game. So we're calling that broadcast method. And in here, we're getting a game state, which is a list of all current players in our server's game. And so we're sending a header over, and then we're sending that game state list over. All right, so let's see for a second. If we head back over to our client in receive pregame state, the first thing that we'll put a little comment here, we'll say wait for a new player to join and receive their information. So we'll get the packet size from our header, and so we're inside of the game now. So we'll say self.connection. The game has a connection object, and that connection object has our player socket. We want to receive. The size of this is going to be our self.connection.header length. And then we have to decode this. So we'll say .decode, and inside of here we'll pass our encoder, which is inside of our connection object. So self.connection.encode. Encoder. Right, yeah, we said it was encoder, not encode. Okay, so now we've got the packet size of that next packet that's coming in, and that next packet that's coming in is our game state. So we'll say game state JSON is equal to self.connection.player socket dot receive. How big is this packet going to be? Well, it's going to be the integer value of the packet size that we just received. And we're not going to worry about decoding it here because we're going to let JSON do the decoding and turning it back into a dictionary for it, or a list for us. Right now, this is a string, but if we say game state is equal to json.loads and we pass in the game state JSON, it will take this string, it will, which is encoded, it will decode it and turn it back into a list for us. Awesome. So now we've got an updated game state here from the server. Our local game on the client has a game state attribute. Let's set it. So we'll say self.gamestate is now equal to the game state that we just received. Awesome. Now, we just received an updated game state in this method for when a new player joins the game. Even when we join the game, like this specific player, will get an updated game state. So that means we can now increase our player count by 1. So we'll say increase this game's player count. So we'll say self.player count plus equals 1. So now imagine if we scroll back up here, we had originally said player count was player number minus 1. So if you were player number 3, 3 minus 1 would mean that there were 2 players already in the game. And then when you join, this local game would get a broadcast of a game state, and then we would increment this to be you are finally in the game, you are the 3rd player. So I think that's going to work out pretty nicely. Once all of the players have joined, we'll break out of this while loop, and what we'll do, we'll say all players have joined. We will update our status message for the player. So we'll say something like we'll say, self.player.status message is equal to press enter to play. I think something like that would look pretty good. So once everybody has joined, we'll give some indication that like, hey, we want you to press enter and to signal that you are ready to play the game. All right, so let's test this now. So now if I run this, all right, server's in, we're running this. We're passing information back and forth and back and forth and back and forth. And we get no errors, which is great, but we still get no visual confirmation that anything is actually working. Like, do I have a player object? Where is the player object? What are its attributes? We don't know. So we'll close out, we'll close out, we'll close out, stop everything. And it's a simple fix. We just have to write the game class's draw method here on the client side. So it's the draw method that's essentially going to put everything onto the screen for us. So I'm going to scroll down. Here's our draw method. If you notice, if I go down just a little bit further, we are calling this draw method inside of our main game loop. So this will get called every iteration of our game loop, which is perfect. So inside of here, let's take a look at what we want to do. Now, we don't want to just draw our own player's information here. Rather, we want to draw every connected player's information. And that is all stored in the game state attribute that we just received from the server. So what we're going to do is we'll loop through each opponent's current state in the game state. So we'll say for player in self.gamestate. So if you recall, game state is a list, and it has a bunch of like player JSONs, we should say. So these are strings right now. So what we're going to do is we'll turn each string player back into a dictionary, and we'll use JSON to do that. So we'll say player is equal to json.loads, and we'll pass in the string version of that. So now we have a dictionary right here, which means we can access its key and value pairs and do things like draw the given opponent. We'll say draw the given player. I shouldn't say opponent because you want to know why. We're in here. We're in here. So we'll say loop through each player's current game state because we are one of the players that is in this game state list. It's not just our opponents, it's all of us. And so now we'll draw it. So let's see, we'll say pygame.draw dot rect. And inside of here, this means we're going to just draw. We're just doing simple rectangles, simple shapes. We need to put the surface that we want to draw on. It's the display underscore surface. That's the name of our Pygame window. We have to pick the color. So the color will be the player's primary color. So P underscore color. So if it's red or blue or green or yellow. And then we have to specify kind of like a rectangle coordinate that we want to draw. So like where to start the rectangle and how wide and how tall the rectangle should be. Well, hey, that's stored nicely in the player's coordinate key. So we'll get those values right there. Awesome. So that will draw all of our players onto the screen at their starting location, essentially. But then what we want to do is we want to give some indication as to which player this person is. So what we're going to do is we're going to actually outline this player that's on this client. We're going to outline their square in like a bright magenta color. So we'll just say draw a magenta outline around this player to highlight. So to do that, we'll use pygame.draw.rect again, and we're going to draw to the display surface. And we want the color to be magenta, which we had previously defined. And then we want to draw it at this player's coordinates, so self.player.coord. So this is our player attached to our game, which is running on this client. And then to just do an outline, you just have to put an integer value next, specifying like the thickness of the outline. For right now, I'll just do 2. So that will not fill it in. We won't fill the rectangle in. It'll just do an outline. All right, now let's just do a few more things here in the draw method that I think will help us. Let's create a round time text and draw. So we're going to be keeping track of the round time. Let's create a text object for this. So we'll say time text is equal to, we had a font that we declared earlier, so we're going to take that font and we're going to render something to a text object. So we'll say round time colon space plus the string representation of self.round time. All right, and then we're going to set anti-aliasing to true. Although, you know what? I think round time might be a string itself. I'm not sure. I'm just going to cast it to a string just to be safe. Anti-aliasing is true. We'll always have it be true. And then we'll set the color of this text to be white. Now that we have that text object, let's create a rect for that object. Oh, and if you notice, I'm not using an f-string here. I think f-strings gave me problems when I was trying to render text objects, so I just used string concatenation, which is why I'm casting that to a string right here. We'll get a rect so we can position this text object. So we'll say time rect is time underscore text dot get underscore rect. So now there's a rectangle around this text object and we can position it. And I will position it time rect using the center attribute dot center. And I want the center of this rect to be in the x direction right in the middle of my window. So window underscore width. And we'll use floor division to get an integer divided by 2. And then in the y value, I'll just put it down 15 units. So it'll be like right here in the vertical direction. Now that we've got the time object and the time rect and they're positioned where we want them to be, we can blit or copy this object to the surface. So we'll say display underscore surface dot blit. And in here, what do we want to blit? The time text. Where do we want to blit it? To the time rect. Awesome. And the last thing that we'll do here before we test this all out is we'll do a similar thing for our status message. So the player has a status message that is going to change throughout the scope of the game, kind of giving some visual feedback to the user as to what they should be doing. So we'll say status text. We'll say, actually, let me put a comment here, create the player status. So we'll say status underscore text is equal to font.render. And then in here, we'll just say our message is self.player. So we'll get our player object, and we're going to get its status message. So self.player.status message, anti-aliasing is true, and the color is going to be white. We'll get a rect for this message. So we'll say status underscore rect is equal to status underscore text dot get underscore rect. And now we'll position the rect. And I'll use the center attribute again. So I'll say status underscore rect dot center is equal to, and this time I want it right in the middle of my window. So window underscore width divided by 2 and window underscore height divided by 2. And now that I have the text object and it's positioned, I will blit or copy it to my display surface. So display surface.blit. And what do we want to copy? Our status text. Where do we want to copy it? At our status rect. All right, so now with the draw method complete, let's test this and see if we actually get some visual confirmation that all of the hard work that we've done up to this point is actually working. So I'm running the server, I'm going to run my client. Hopefully it will get a player object, it will draw the player object to the screen, and we will see it. Well, we look in our main game loop because that's where we're emptying out the event queue. So I'm going to scroll down to our main game loop. Here is our main game loop, and you can see right here for event in pygame.event.get, we are emptying out the event queue. And we're checking right now to see if a given event is of the type quit. And so that's great. But now we also want to check to see if there is an event of type key down. So if someone pressed a key. So we'll say if event.type is equal to pygame.key down, someone pressed a key, we now want to see what key was pressed. All right, we're telling the user that they should press enter in order to advance the game. So we'll say if event.key is equal to pygame.k underscore return. Return, make sure you spell it right. So Pygame calls the enter key return. So that's how we'll check to see if the user is pressing a key. If it is the enter key, what do we then want to do? Well, we want to make sure first that we put some checks in here. We only want to advance to the next state of the game, signaling that maybe the player is ready to play, if the player is currently waiting. So we have a flag is waiting. So we're going to say if the game has not yet started, so that means there is waiting flag is set to true, and all players are in the game. We want to make sure that all of the players are in the game before we advance. So we'll say if my player, that's what we're outside of any class right now, so our player is called my player. So if my player dot is waiting, and my game, so our game object, if you recall, our game object has a player count attribute. If my game.player count is equal to the game's total players, so my game.total players. So that means everyone is in the game. Well, what should we do now? Well, I think our game has a method called readyGame. That will indicate that we are in fact ready to play. So let's call that method. We'll say myGame.readyGame. And we should go write the readyGame method right now. So I think we got to scroll up for readyGame. We just have to find it. So if I scroll up, scroll up. readyGame is right here. So here is our readyGame. So if the player hits enter under the right conditions, then we are going to signal that they are in fact ready to play the game. Thankfully, we have lots of attributes to our player to help with this, and these are going to be our Boolean flags. So let's look at them now. We've got a is waiting and is ready flag. We got to change those. So we're going to say update status flags for the player. So to ready the game, we're going to say self.player. We're inside of the game, so we're going to reference the player object, and we're going to take its is waiting flag. The player is no longer waiting. We're going to set that to false. The player is ready to play the game. So we'll say self.player.isReady, and we'll set that to true. And let's also change the status message of the player to like a useful message here. So we'll say self.player.status underscore message is equal to ready waiting for other players. So we'll say we're just waiting. You're ready, but we got to make sure everybody is ready before we start. So now we've changed the player's state on our client side, right? We've updated some player flags. What we now have to do is we now have to send this changed state over to the server so it can be processed. And thankfully, we have a method here on our client side called sendPlayerInfo. So what we need to do is we'll call sendPlayerInfo, send specific info about this player to the server. We'll call this method and send over these changes. So inside of readyGame, we'll end it here by saying send updated status to the server. So we'll say self.sendPlayerInfo. And I guess we're here. We might as well write send player info next, right? In terms of our logical progression of what we need to do, that's the next thing. So I'll scroll down to send player info. We'll get rid of our pass here, and then let's write this method. So we'll start by saying we're going to create a dictionary of pertinent items to send over to the server, the things that will potentially change from our player. And really, what's changing is their coordinate and their status flags. I don't think here there's no need to send the whole player object over, so we're not going to do that. We'll build our own dictionary. I think it'll just be a little easier. So we'll say create a dictionary with items to send, and so we'll call this dictionary player info. And the first key will be coord for coordinate, and we'll get its value from our player object, self.player.coord, their coordinate attribute. And then we'll get the three status flags. So is waiting, and we'll do self.player.isWaiting here. Then we'll do is ready, and we'll plug in self.player.isReady. And then the last one is our is playing flag. So is playing. Now we didn't make any changes to this flag, but we will eventually, and we're going to use this function over and over again, so or method over and over again. So we might as well send it here. So is self.player.isPlaying. All right, so now with our dictionary built, we'll turn that dictionary into a JSON, get a header, and send it over. So let's send the dictionary to the server. All right, so first thing that we'll do is let's turn the dictionary into a JSON object so we can encode it. So player info JSON is equal to json.dumps, and we want to put in our player info here. So now this dictionary has become a string, which is wonderful for us because we can encode that string, we can get the length of that string, all those good things. Let's get the header. So we'll say header is equal to the length of player info JSON. So this will get how big this is, but this is going to be an integer. We want it to be a string so we can append some white space to it easily. So while the length of header is less than the header length, which is stored in our connection object, so self.connection.header_length. What do we want to do? We want to add some white space to our header. So we'll say header plus equals a blank space. This will ensure that our header is 10 characters long, and now we'll send our header over. How are we going to send? Well, we're going to use our connection object, self.connection, and we'll access the player socket of the connection object, .send. What are we sending? We're sending our header, and we have to make sure we encode it. So .encode, and inside of here, our encoder is self.connection.encoder. Awesome. Now that we've sent the header, let's send over the updated player information. So self.connection.playersocket.send. Here we're going to send player info JSON. This is a string, which is great because we can encode it if we spell encode right. And now we'll pass in self.connection.encoder to get our encoder. All right, perfect. So now, if you think about it, each individual client is going to hit enter at different times and be sending in some updated player information to the server. So this means that the server has to always be listening for this incoming message for each and every connected player. We don't know when they're going to come in. Someone might take 1 second to hit enter. Someone might take 1 minute to enter. So this should definitely be run in a thread. So I'm going to save our client file here. I'm going to come back to our server, and if we go to our server and we take a look at our game object's connect players method, which is right here, we're inside of our game object. So game object connect players. If we look here, we'll see that when a player connects, after we broadcast to all players that this player has joined the game, this is probably where we should be listening for some feedback coming back from a connected player. And we want to make sure we do it for every single connected player. So here we got to make a thread for this particular player that just joined the game. So I'm going to call this thread ready thread. So if you look at this point, we haven't really made a thread here on the server side. We're accepting any connection, And we're just getting player sockets and player addresses. We're making players, making player sockets. We're sending them over to that specific socket. And right here now, once we've alerted that a new player has officially joined, we're going to create a thread to monitor the ready status of this player. And so to do that, we'll call this ready thread, and we'll say threading.thread. And inside of here, we need a target. So what is our target going to be? Well, we're looking to we're trying to ready our game, right? Oh, look at that. We've got a ready game method here on the server. Ready the game to be played for a specific player, and that's exactly what we want to do. So we'll target ready game, and we'll make sure we have the arguments of a player and a player socket, which inside of our connect players method, we have a player socket right here. And if we look, we have a player. So this is going to work out really nice for us. So we'll target in our ready thread, we'll target our ready game method, and we'll say args equal, as an iterable, we'll do player and player socket. Awesome. Now that thread has been created, let's start the thread. So we'll say ready thread.start. Awesome. So now what we should probably do is we're starting the ready game thread. We should go write ready game. So let's scroll down to our ready game method right here. We'll get rid of pass, and let's figure out what this method needs us to do. So first in this method, what we're going to do is we'll simply wait to receive the pre-game player information from the given player over the given player socket. So we've got a player and a player socket for this, right? And this is going to be running in a thread for every distinct player and their distinct player socket. So we'll say wait till the given player has sent info signaling they are ready to play. So that means, right, I'll just reiterate this one last time. We're going to broadcast that a new player joins. We send them the information they need for the game window. We send them their player. We broadcast to everybody that this player has joined, and then we start monitoring whether or not they have hit enter to start playing the game. Of course, this client can only hit enter once everybody is in the game, but when that happens, we're just going to sit around and wait for some information to come in, because when they hit enter, that's when our ready game method will run on the client side. We send some player information over, which is going to be our updated status flags. So we're going to just sit here in this thread and wait until we receive some information from the player. Now, if you think about it, we want to receive information from the player here on the server side. We have two specific functions or methods that are going to help us do that: receive pre-game player info and receive game player info. Well, the game has not yet started yet, so we should call receive pre-game player info. So we'll say self.receive pre-game player info. And we'll pass in our player and our respective player socket for the thread that this is running on. Awesome. So maybe we should go and write this method right now. Let's go take a look at it. So receive pre-game player info. If we scroll down, receive pre-game player info. Make sure you're in the right thread here, or in the right thread. Make sure you're in the right method. We want to make sure you're in the pre-game one. We know we're sending over a header, and then we're sending over a player info like dictionary with updated status flags. So let's get the header first, which is going to hold our packet size. So I'll say packet size is equal to. Here we have the player socket that we want to communicate over. So we'll say player socket dot receive. The size is going to be in our connection object. So self.connection dot header length, because this is one of our headers, and we have to decode this. So dot decode self dot connection dot encoder. Awesome. Now we'll get the player info JSON that's going to come in next. So we'll say player info JSON. This is the dictionary of all those updated values. So we'll do player socket dot receive. How big is this packet going to be? Well, it's going to be our packet size. So integer of packet size. I just said packet size, which is kind of funny to me. But if you remember, when we get this is going to be a string. So we want to turn it back into a dictionary. So we'll say player info is equal to, we'll use JSON. JSON dot loads, and in here we'll pass player info JSON. So this will decode and turn that string back into a dictionary for us. So now we've got a dictionary of updated player values. Well, we've got a player over here on our server end that we need to update for our records of the server. So we should go see, does our, I think our player, so I'm just going to highlight this so we don't lose our spot. Our server player, if we look, here's our player, we've got its initialization, and it's got a set player info method that requires some player information in the form of a dictionary, the coordinates and status flags. So let's call set player info right here, and we'll use this method to update our copy of the player. So we've received some updated player information, so we'll say set the updated values for this player. So we'll do player. We've passed in a player object. And again, this is going to run in a thread for each and every player object. So take this player object, and we'll call set player info, and we'll pass in the player information. Well, we're calling set player info, so I bet you know what we're going to do next. We are going to go up and write set player info on our server. So we'll scroll up. Here we are inside of the player object. And so let's get rid of the pass, and let's talk about what we need to do inside of set player info. Well, it's pretty straightforward. We have a dictionary, player info, and it's got a bunch of key and values. Let's just go look at what those key values are. We've got on our client side, here it is, send player info. We got coordinate, is waiting, is ready, and is playing. So we're going to update our player on this end. So now, be careful, we are in the player object, right? We're in the player object. So we'll just reference the player as self here. So I'll say self.coord. We're going to update our coordinate attribute is going to be our dictionary, player info, and we'll use the coord key. There's our new coordinate. Self, and we'll do something similar. Self.isWaiting is equal to player underscore info. There's our dictionary, and we'll use the isWaiting key. Self.isReady is going to be player underscore info, and we'll pass in the isReady key. And then lastly, we have our isPlaying flag. So self.isPlaying is equal to player underscore info is playing. Hey, I think that's it. So now when we call that, we pass in some new information, right? Well, we received new information from the client. We received it, we put it into a dictionary, and now we're passing it into the set player info and updating our players' records over here. Awesome. So now that this is all done, I think we can go back to our game's ready game method. So if we scroll back down, here is our game's ready game method. So, right, we said when someone joins the game, we'll do all that update stuff that we did, prior. We'll create the game player, send it over, and then we'll monitor if this specific player is ready to play. The way we get confirmation is they send us something over. So when they send us something over, now we receive it, we turn it into a dictionary, and we update our player values for this player based off of what just came in. So now what should we check? Well, we should check to see if the players, this particular player's status flags have changed. So we'll say if this player is ready to play, what are we going to do? So if player.isReady, so if that status flag has been set to true, we want to proceed only if all other players are ready. So we'll say while true. We're going to just be in an infinite while loop. So I don't care if this player is ready. I mean, it's important, but what I really care about is all other players being ready. So once we have confirmation that this particular player is ready, we will loop infinitely until we get confirmation that every single player is ready. So how are we going to do that? Well, we'll just say check if all players are ready. We'll create a Boolean variable. We'll call it I don't know, what do I want to call it? I'll call it game start, and I'll set it equal to true. And what I'll now do is loop through all of my player objects that are connected to the server. If you recall, the game object here on the server has a list of all of these player objects. So I'll say for player object in self.player underscore objects. I'm just going to scroll up to show where we define that list. I know it's been a while. In our game's initialization method, we have two lists that help us here: player objects and player sockets. And so every time we create a new player, here's our connect player method. Every time we create a new player, we append that player to this list. So we've got a list of those. So we're going to loop through each and every one of these player objects. And what do we want to check? Well, we're going to look to see if one of those players is not ready to play the game. So we'll say if player object dot is ready, if their is ready flag is equal to false. So that means if one player is not ready, then the whole game is not ready to play. So we're going to take game start, this boolean that we just defined, and we'll set it back to false. However, if we loop through every single player in our object or our list of objects, player objects, and not a single one is not ready, then that means every single person is ready to play the game and we should advance. So outside of this for loop, I'll say all current players are ready to play the game. I'll say if all current players. And so how are we going to signal this? Well, we're going to say if that game start variable is still true. So if game start, then we'll take this particular player, and we'll set its is playing flag to true. And this will happen in all of the threads because, remember, ready game is running in a thread for this particular player, so we're only going to set this particular player's flag to true. And for right now, I will print a visual confirmation on the server. We'll say playing the game. And now, if we're going to play the game, we're going to start the game. It's important to mention that we said the timing aspect of the game is all going to be done by the server. The server is going to keep track of time and then push that time out to each individual client. And I think that's the better way to do it, because if we keep track of time locally on each individual client, well, there could be some issues because certain games might run faster than others and the times might not be synced. And that would be really bad, like if one game finished but another game was still going on. So we'll start a clock on the server for the game. And so to do this, we're going to create a new attribute. We're going to call it start time. So self.startTime. The time where we started playing the game, we can use the time module. If you recall, we imported the time module. And so we'll use the time module here. And we'll say time. We'll call the time method. So this will get like the process time, like a computer time, and I think it's in like seconds since the dawn of something. I don't know. It's a weird number. I'm not fully sure. But it gives us a time that our computer can reference. And so we'll start it now, and then what we'll do is we'll check what that current time is, in different iterations of our game loop, and we'll just subtract the two to get how much time has essentially overlapped. Now that the game has started, what we can do is we can break out of this infinite while loop that we were running, and we'll move on to the next part here. So I think this is going to work pretty nicely. Let's actually test this now, and let's see how this works. So I'm going to run the server. So the server is starting. I'm going to have one person connect. So they connect, they get all of the gameplay information from the server, they create a window, all right, and it looks like I have an error here. Ready game is not defined. So this is in my server file on line 158. Did I forget? Oh, I'm on my client. Silly me. On my server file on line 158, ready thread is equal to threading.thread target. So I targeted ready game. That's a big mistake here because ready game exists inside of the game class. And so how do we show that this method is attached to our game class? We need the self keyword. So I forgot self.readyGame right here. So a quick fix. Hopefully that is our only error, but our this program's getting pretty large in scope. So we're going to get errors, we're going to make mistakes, and we have to learn how to debug them. I think it's a good skill. All right, so here is our first game window. Perfect. So we connected to the server. The server sent over our game configuration. We built a window. The server sent over a player object. We built the player object. And now we're sitting here just waiting for everybody to join. If I run it again, we're going to do the exact same thing, except now, if we look, we have our maximum number of players. And so really what we have just done is on the server, we have two threads running right now. A thread listening for confirmation from our first player, player 1, and our thread listening from confirmation from our second player, player 2. And so let's hit enter. Let's see if I hit enter. All right, so that's great. The status message has changed to ready, waiting for other players. And so now I'm going to hit enter here. And it says ready, waiting for other players. And if you notice, we've got no visual feedback that the game has begun on the client. But look at our server. It says playing the game, playing the game. So that means this is working out perfectly. Recall, this method is running in a thread for each and every connected player and their respective player socket. So, I just want you to remember this. So let's remove our print statement here that we were printing at the bottom. We were just giving confirmation on the server and playing the game, which is why, if you remember in our last video, it printed playing the game twice because I had this method was running in two threads, so each thread printed it because we had two players playing. So we're actually going to delete that print statement right here, and outside of the while loop, once we break out of the while loop, what do we want to do? Well, we have updated a player's flag. We've updated the is playing flag to be true. So I want to send the updated status flags back to our given player. And so the game object on the server side has a method, send player info, that we can call to do that. So outside of the while loop, once we break out of this while loop, indicating that the game has officially started, we'll say send updated player flags back to this player. And so we'll call the game's send player info method. And that is going to require a specific player that we want to target and their respective player socket that we can use for communication. And so if you look, that method is right here. So send player info. So in here, what do we want to do? Well, we're going to get rid of pass. The first thing that we should do is probably compile a dictionary called player info, and that will contain all of the pertinent information that we're altering over here on our server side. So we kind of did something similar. I'll just highlight this so we don't lose our spot. If I come back over to the client side, we had a send player info method, I'm sure. Yeah, here it is. So we created a dictionary called player info. In here we had the coordinates and our status flags. On the server end, we're just going to do our status flags. I'm not going to alter the coordinates necessarily. So we'll just do our status flags, and then we'll create a header and send it over, just like we did here. So on our server, send player info, the first thing we'll do is we'll create a dictionary with the status flags for this particular player. And again, this is going to be all running in a thread for each individual connected client. So we'll say player info is equal to, here is our dictionary. We'll have a key called is waiting with the associated value of our player objects. So player, the player is right here. So player dot is waiting. All right, we'll do an is ready key, and we'll say the value is player dot is ready, and then we'll do a is playing, and the associated key is player dot is playing. Perfect. So now that we have created the dictionary, let's turn it into a string with JSON. We'll get a header, we'll encode, and we'll send it over. All that good stuff. So let's walk through doing it. We'll say send the player info over to this player. So we'll say player info JSON. We'll turn our dictionary into a string using json.dumps, and we'll pass in player info. So dictionary, you can't encode it. We turned it into a string. Look at that. We can encode it. So now we'll get a header, which is going to be the size of that string. So we'll get the length of player info JSON. But like we said, this returns an integer. We want it to be a string, so we'll cast it to a string. So now I can append some white spaces until it is the correct length. So we'll say while the length of header is less than our header length, which is stored in our connection object, self.connection.header underscore length, we'll add some white space. Header plus equals a white space. That will ensure that the header is the right size, so that on the other end we know exactly how much data to pull from the data stream. And we'll say player socket So we want to send now. We want to send using this socket that's right here in this method. Player socket dot send. We're going to send the header dot encode, and we will use self dot connection dot encoder. And then we'll send our player info JSON. So we'll say player socket dot send player info JSON dot encode. We got to encode it, and we'll use our encoder self dot connection dot encoder. All right, I think that looks pretty good. So we built our dictionary with our updated flags. In this particular one, we are changing the isPlaying flag, and now we're going to send it over. So since we're sending updated player information for each and every connected player, the client script should probably be listening for this information. So I'm going to save my server, and we're now going to head over to our client side. And the client should always be listening for this incoming information. So we should probably run it in a thread. And I guess the question is, where should we call this thread? Well, we should call it inside of the game's ready game method. Since it's here, we're indicating that, hey, this particular player is ready to play the game. So now I want to listen for an incoming message from the server to indicate that all players are ready to play the game. So on my client, I'm going to go to the game's ready game method. Where is it? Ready game, right here. And let's add some stuff here. So client yep, perfect. So inside of ready game, right here we've sent our updated status to the server. We said, hey, we're ready. So now we should begin listening for the status of all players being ready. So we'll say monitor for the start of the game from the server. All right, so we'll call this start thread, and it will be threading.thread. And what do we want to target here? Well, we want to start the game, so we've got a start game method. So we should target this. We'll say target is equal to self.start game. Start game has no arguments, so we don't have to use the args here. And let's just start this thread. So we'll say start thread.start. Okay, so you betcha, you know what we're going to do next. We're going to go write start game. So we're calling the start game method right here in this thread. So let's go write start game now. So inside of here, we want this thread to continually run until we get confirmation from the server that the game is in fact starting. So I'm just going to use I'll use an infinite while loop. I'll say while true. I guess we can do it this way. We'll say wait to receive information from the server that the game has started. So I'm just going to wait until the server sends me something back. So I want to receive some updated player information. I believe we've got send player info. We've got a receive player info. So it says receive specific information about this player from the server. We have to call it right here. So we're waiting to get some more updated flags from the server. And so we'll say self.receive player info. We'll call that right here. Why don't we go write receive player info right now, since we're calling it? All right, so here is receive player info. Inside of here, what do we need to receive? Well, the server is going to send over a header which is going to contain information about the next packet's size, and then they're sending over that player info JSON with the updated player flags, the updated status flags. So let's get both. We'll say packet size is equal to, we need to get our socket, which is stored here. We are in our game object. Our game object has access to a connection, so self.connection, and that has the player socket, so self.connection.player socket. We want to receive. We're going to set our header length, self.connection.header length, as the byte size. And then we need to decode this, so .decode, and we'll pass in our encoder, self.connection.encoder. Awesome. Now that we have that, let's go grab the player info JSON that's going to come through. So player info JSON is equal to self.connection.playersocket.receive. And here, the size of this packet we've specified is the integer value of our packet size. So we're going to grab exactly the amount of data we need from the data stream. We don't have to decode it because JSON is going to decode it for us when we take this string and turn it back into a dictionary. So we'll say player info is equal to json.loads, and we'll pass in game state. I lied there. We're going to pass in player info JSON. Perfect. So string. This is an encoded string. It's going to decode it, and now we have a dictionary. So now right here, if you think about it, we have a dictionary of updated player information. We need to set that player information to the player on our client side. So we'll just say set the updated flags for the player. And you know what's nice? I'm pretty sure our player has a method, the player object here on the client side has a method called setPlayerInfo. And this mimics exactly the kind of thought process we had done on the server side. So let's call our player object. The player is attached to the game, self.player.setPlayerInfo. And we'll pass in this dictionary of player information. Why don't we go write set player info now for the player object on the client side, since we're calling it. So here is our player, right? Player, perfect. And we'll scroll down. Here is set player info. So what do we need to set in here? Well, if we look back at our server, what did we send? We sent 3 status flags. So we have to set the updated value of those 3 particular status flags. All right. Easy enough. So we'll say we're inside of our player. So remember, if we're inside of our player, to reference our player, we're just going to use self. So we'll say self.isWaiting is equal to the player info dictionary we passed in, and we'll look at the isWaiting key. Then we'll do self.isReady, and we'll pass in our player info dictionary, and we'll use the isReady key. And then we will do self.isPlaying. Our last status flag is the dictionary player info, and we'll use the isPlaying key. Perfect. So now I think we're actually set to go back to our start game method now. So, you know, it's funny because I think we did the exact same thing kind of on the client side, right? We said, okay, we're going to run a thread where we're going to try to receive some information, but we got to go write a couple other methods before we can actually finish what the thread was meant to do. So now when we, if we just kind of like walk through this, under ready game, we are going to hit enter. So our status flag is set to true. We're ready. We send that information to the server. The server gets it under ready game. Yep, the server gets it because we're watching to see if that individual player is ready, and that happens here in ready game. The server gets it right here, and then they wait infinitely until all players send it. When all players send it, then we update their status flags to being true, is playing is true, and then we send it back. When we send it back, we're going to wait to hear for it to come back. We're going to monitor this thread. We're just going to sit here and wait till we get that information back. And once we get that information back, then we receive the player info, which we've already written, and then we set their info, which is going to change. The most important thing is it's going to change the player's is playing flag. So now here we'll say if our player, we're in the game object now, so we have to reference self.player.isPlaying. So if that is playing flag has successfully been set to true, then what does it mean? Well, it means the game is on. So the game itself is active. And if you recall, our game class has a Boolean is active, which was false. We are now going to set it to true here. So under the start game, we'll set self.isActive equals to true, and the players has a few Boolean flags. We've already set the players is playing flag to true, but what I now want to do is set their ready flag to false. They're no longer ready. They are actually playing the game. So we'll say self.player.isReady. Let's set that flag to false. And then what we should do is update maybe our status message. So we'll update our status message. We'll say, I don't know, let's do self.player.status message is, we'll just simply say play. I guess that's a pretty good status message for when the game is going. And then once that's all done, we will break out of our while loop. Okay, so I think that's probably like the last thing that we'll do. And so now at this point, gameplay should begin. So let's run this and test this and see if everything works up to this point. And you know what I'm going to do on my server? Why don't I just change? I'm going to change some of these variables here. So I'm going to do 600 and I don't know, we'll do 60, sure. And let's do, have we tested it for 4 players? Let's actually see, do we get all 4 people in? So I'm just going to run it for 4. Let's see. All right, incoming connections. We'll run our client and let's see if everything is happening the way we want it to be. So there's our first player. Looks great. All right, let's do our second player. All right, now we got 2 people joining. Awesome. We got 3 people joining. Very good. All right, there's blue. Looks great. And then our last one should be yellow. I don't think we've actually tested this for 4. So let's just see. So, all right, all 4 people are in. 4 players in game, no longer accepting new players. Great. Let's bring up all of these windows here. Zoop, zoop.